Good evening, everyone. Hello and welcome to everyone. I'm delighted to see all of you here this evening. We are at our appointed hour, and so I want to make sure that we get started so we have enough time to celebrate and listen to all of our competitors, and then also have some time together out in the Galleria. So I'd like to officially welcome all of you here this evening, those of you who are here in person and those of you who are watching online. And this is the 2025 3MT Final Event Competition for the University of Manitoba. Now, before we begin this evening, I would like to acknowledge that the University of Manitoba campuses are located on the original lands of the Anishinaabe, Aninawuk, Anisinaninawuk, Dakota Oyate, and Dene, and on the homeland of the Red River Métis. Myself, as a settler who lives, learns, and loves on these lands, I acknowledge the harms and mistakes of the past and those that continue into the present. And I dedicate myself to move forward in partnership with Indigenous communities in a spirit of reconciliation and collaboration. To begin our event this evening, it is my pleasure to introduce Dr. Michael Benarosh, President of the University of Manitoba. He is a proud supporter of the 3MT competition. Dr. Benarosh is a strong advocate for graduate education within and beyond our institution. So please join me in welcoming him here this evening.
Thank you, Kelly. And I'm great to be here. I've always enjoyed these competitions. I'm amazed at how much people can say in 3 minutes. I've been told to keep my remarks to 180 seconds, so the clock's not going yet. But I just wanted to say to the competitors, thanks for taking the time, for taking the risk of doing this, for involving yourselves in this practice. And I think my hope is that this will have positive impacts on your ability to interview, to explain your research, to interpret the work that you're doing to a wider audience, because I think that's such an important part of doing science and teaching science. I hope that you've learned a little bit about communication skills as you've gone through this. I believe that graduate students are the foundation of the research enterprise at the university. Skilled labor that our province and our country desperately needs. And so I'm really excited to hear some of your work today and the challenges that you've undertaken. I also want to thank Colleen for this is like our annual meeting. We meet once a year on this day, for coming and emceeing again today. And I wish everybody the best of luck. And now I'd like to call on Diane Hebert-Murphy, Provost and Vice President Academic, to bring greetings. It still says 3 minutes, so I did it.
Thanks, Michael. I don't think I've ever heard the President speak for only 3 minutes. Well, good evening, everyone. It is my pleasure to be here. I love this event. I am always amazed at our competitors, and it's just such a joy to see the research that our graduate students do being showcased in this way. As a U15 research-intensive university and the only one in Manitoba, we are committed to research excellence, which includes the skill of being able to take the knowledge that we are generating and share it with the broader community. We're going to witness today students who are taking what is very complex and sometimes highly technical research and communicating that to us in ways that those of us who have no exposure or knowledge of their discipline can understand, both understand what they're doing and why it's important. And I think you can all agree that it is quite a challenge to take complex concepts and boil them down into a very concise and clear message that can be shared with a lay audience. I want to just take a moment to thank a few people. First of all, I want to acknowledge all of the faculty members who are involved in providing our graduate students with an excellent education. If it wasn't for our faculty and the expertise and the skills that they bring in research, we wouldn't have research-intensive graduate programs, and we wouldn't be hearing about the kind of work that these students are engaged in. So thank you to the mentors and all of those of you who are supporting our graduate students across the campus. I also want to acknowledge and thank our staff from the Faculty of Graduate Studies. It is no small undertaking to organize the 3MT competition, not just tonight's gala and final, but to organize all of the heats and get to this point. So thank you for your ongoing commitment to this competition. And I want to congratulate all of our competitors today. You've already had great success in being here. So I hope that you can actually take a minute and enjoy the event. I know there's probably some nerves happening, but really, we're so proud of what you've already accomplished, and we're very excited to be here. To hear from you, and I think I'll probably speak for the entire audience to say we are ready to be amazed by what you have to share with us today. And now it's my pleasure to introduce to you Dr. Annemieke Fahrenhorst, who is an Associate Vice President of Research here at the University of Manitoba.
Good evening, everyone. I think I'm the only one that's allotted a full hour here today, so that's the good news. But thank you so much. Thank you, Colleen, for hosting this event, and congratulations to the finalists for being here today. It's a great pleasure to be here as the Associate Vice President Research. You can imagine that research is my passion. And I know that among the many challenges that researchers have is actually communicating to an audience that is not in their field of expertise. And you can imagine that doing so in only a few minutes is even more challenging. So congratulations and good luck tonight. So when we're thinking about communicating about research, it's really key to showing the impact that you make of your research on society. Knowledge translation is an art on its own, and I'm sure that today participants will impress the jury, and I know where they're sitting. You will demonstrate your knowledge, your learning, and I think it would be a great event. So over the years, this competition has grown to become the highlight of our winter term. This competition is an important opportunity to learn about the groundbreaking research of University of Manitoba graduate students. And the University of Manitoba has almost 4,000 graduate students, and it fluctuates. Currently, the exact number is 3,785, and there are some of them. I'm glad to be learning about a diverse range of research tonight, and I know that graduate students are key contributors to the University of Manitoba research enterprise, regardless whether you work mostly independently or in a very small or very large research team. You are the one that pushes the boundary of knowledge and help grow University of Manitoba's national and international reputation. I would like to thank all graduate students for participating in that, from the initial entrance to tonight's finalists, for the time and effort that you devoted not only to your research, but also to this competition. You are our future scientists, our future business leaders, our future community activists, and our future government policy makers. The passion and belief in your work will ensure that University of Manitoba remains innovative and competitive as one of Canada's leading research universities for generations to come. Best of luck with the finals, and thank you very much for being here.
Thank you very much to Dr. Benarosh, Dr. Hebert Murphy, and Dr. Fahrenhorst for being here tonight and showing your support of all of our graduate students. As many of them have mentioned, we are delighted to welcome back Colleen Breedy. She has been our MC for this event since 2022. She is an integral part of the finals for 3MT, and she brings much needed enthusiasm and professionalism, and we're delighted to have you back yet again. Colleen is the weather specialist and host of the Spotlight Entertainment segment for CTV News at 5 and 6 o'clock. She's a proud University of Manitoba alum. She earned a Bachelor of Arts Advanced degree in Political Studies from the U of M. Colleen began her career in broadcast journalism at 680 CJOB in 2005 before joining CTV Winnipeg in 2011. Over the years, she has covered a wide range of topics, including politics, crime, courts, health, and human interest stories before transitioning to her current role as the weather anchor. Welcome back, Colleen, and thank you for emceeing our evening tonight.
Thank you so much, Dr. Main. Well, good evening, everyone, and welcome to the University of Manitoba's 13th annual 3-Minute Thesis final competition. My name is Colleen Breedy, and I am very excited to be back as your MC. As an alumna of the University of Manitoba, it's always such a pleasure for me to stay involved and connected to this community. And really, it is an honor for me to get to come back to campus every year for the finals. I'm always in such awe of the brain power that's on display, and I'm sure you will be too this evening. And actually, Dr. Main mentioned my first year was in 2022, when of course we were in the midst of the pandemic, and this was an entirely virtual event that year. So I was sitting at a computer hosting this event back at the TV station in downtown. So we did it. It went very well, but it's always so much nicer to be here in person with all of you this evening. So with that said, a special welcome to both our in-person audience and to those joining us online. We're thrilled to have you with us for this celebration of research and innovation. 3-Minute Thesis, or 3MT, is an annual competition where graduate students from across the university compete in front of a non-specialist audience and a panel of judges. They must explain their research thesis in plain language in 3 minutes or less. The 3MT model originated at the University of Queensland in Australia, and it has since spread to more than 85 countries and over 900 universities worldwide. Tonight, you will hear from 12 finalists who have worked incredibly hard to refine their presentations. Our panel of judges will evaluate the comprehension, engagement, and communication of each of our presenters. And after the last challenger presents, there will be a QR code on the screen for the audience to vote on their favorite presentation to determine the People's Choice Award. Challengers and audience members will then be invited to a small reception just outside the theater in the Galleria while the judges tally the scores and determine first, second, and third place. Now, at the end of the evening, we will announce our winners, including the People's Choice Award. The graduate student who takes home first place tonight will represent the University of Manitoba at the Western Canadian Regional Competition on May 6th at the University of Victoria and have a chance to compete in Canada's national 3MT competition, which takes place in November. Now, let's meet our judges. Our first judge is Lauren Oshapuk. Now, Lauren is the director of the Partnerships, Knowledge Mobilization, and Innovation Office at the University of Manitoba, where he plays a key role in identifying and evaluating early-stage technologies and helping launch academic innovations out of the university environment. With a PhD from the University of British Columbia, where his thesis focused on nervous system regeneration after traumatic injuries, Lauren brings to the table 25 years of experience as both an academic researcher and technology transfer specialist. An authentic communicator and project manager, his career is marked by a passion for bridging the gap between academic innovations and their practical applications in our community. Lauren, a wave. Hi, Lauren. Thank you for joining us this evening. Our next judge is Mo Levy. Coming from a 30-plus year career in business, government, education, and the charitable sector, Mo has always held a deep passion for entrepreneurship. He led initial development for the Stu Clark Centre for Entrepreneurship with the Asper School of Business and was instrumental in establishing Canada's first business incubator initiative as executive director of the Enterprise Manitoba program. Mo was recognized in 2023 with the UM Distinguished Alumni Lifetime Achievement Award. Welcome, Mo. And finally, Tyler Blashko. Tyler grew up in Winnipeg and has a Métis and Ukrainian roots as well in the province going back more than 150 years. He is currently the MLA for Lagimodiere, the Deputy Speaker, and the Legislative Assistant for Education and Early Childhood Learning. Before being elected, he helped launch Wayfinders, a mentorship program for high school students in Seven Oaks School Division. He's also the past president of the Social Planning Council of Winnipeg. Tyler holds a master's in public administration and lives with his husband and tiny dog, Richie. While he's not working, he enjoys running and watching reality TV. Thank you so much, Tyler, for joining us. Now, to our judges, thank you so much for taking the time with us to be with us tonight, and for choosing the top 3 challengers at this year's event. You're about to find out you have a pretty tough job ahead of you. Now, to the housekeeping rules. Yes, there's always the housekeeping rules. Before we get started with the presentations, we are live streaming tonight's event, so please be aware that any comments made in the audience in the room may be audible on the recording. So in my world, that's called getting caught on a hot mic. It's ill-advised, so just keep that in mind. So also, again, I am but the messenger here, but please make sure that all your cell phones are turned either to silent mode or just right off. Also, we just kindly ask that you be as quiet as possible during the presentations and refrain from clapping until after the presenter has finished speaking. Now, if you do need to leave the room for any reason, please, if you wouldn't mind exiting at the top of the room to the side stairs and come back in that way as well. Volunteers will be stationed at the doors just to make sure they are opened and closed quietly. Now, the doors behind me, to my immediate left and right, cannot be used to exit or re-enter the room unless, of course, there is an emergency. Now, for those who want to join the online conversation on social media, the event hashtags are #3MT, #UMantioba, and #UMResearch. Now, it's time to hear from our finalists. What do you say? It's about that time. Now, first, each presenter will have 3 minutes to share their research using only one static slide, no animations, no props, and no notes. If they exceed the time limit, they will be disqualified. Now, after the challengers have completed their presentation, I'll have the opportunity to ask them a question or two. That will just give the judges a minute or two to make their notes before the next presenter. The questions, just so you know, will have absolutely no impact on the score. It just, as I mentioned, gives the judges just a bit more time to complete their notes and let the audience here and online just learn a little bit more about our challengers tonight. So let's get started, shall we, with our first presenter. Please welcome our first finalist this evening, Anne Manson. Now, Anne is a PhD student in the Department of Human Nutritional Sciences. Anne's thesis title is Using Oxylipins to Inform Dietary Omega-3 Fat Intake and Heart Drug Development.
Did you know that the fat you eat creates tiny but very powerful molecules inside your body? These molecules are oxylipins, and they help control things like inflammation, immunity, and heart function. In fact, painkillers such as Advil or aspirin work by blocking certain oxylipins, which is why they relieve pain and fever. There are hundreds of oxylipins, but until recently, we could only study a few at a time and not very precisely. Also, some oxylipins exist at less than a billionth of a gram in a drop of blood. That's like a grain of sand on a mountain. Now, thanks to new techniques, we can look at all oxylipins. And this is important because since some oxylipins are beneficial and others are harmful, it is the overall oxylipin balance that shapes our health. In my research, I came up with 2 methods to better understand how dietary fats and drugs influence oxylipins and what this means to our health. First, let's talk about diet. We know omega-3 fats are good, but how much do we actually need? Instead of measuring fat levels, I developed a method to look at the oxylipins that they produce. My results show we may need more plant-based omega-3 than we previously thought for optimal health. This led me to another question. Is plant-based omega-3 from flaxseed the same as fish oil? I found out fish oil is about 5 times more powerful when compared with plant-based omega-3s, meaning a little bit of fish oil can achieve what would take much more plant-based omega-3. Now, how can this relate to drugs? Imagine scientists spending up to $2.9 billion developing a new heart drug. This drug was called Varespladib, and it got tested on thousands of people before they found out it made heart disease worse instead of better. What if they had considered oxylipins? My second method showed that while this drug reduced the harmful fat, which was expected, it actually did not reduce the harmful oxylipins that this fat produces. Worse, it decreased beneficial oxylipins. This knowledge could have prevented a costly drug failure, which besides saving billions of dollars, could have also protected people's health. By factoring in diet and sex, my research might help explain why heart disease affects men and women differently and how personalized nutrition could help. My research shows that by studying oxylipins, we can shape our diets for better health and create smarter, safer medicines. Thank you.
Thank you, Anne. Now, since this is fresh, you've just finished, tell us a bit about it. Just explain how, trying to explain years of research in 3 minutes. How did that feel?
It's a little bit challenging. I think this is especially true since I am at the final stages of my PhD. So right now I'm writing my thesis, and what I just talked about encompasses 4 different manuscripts. So it's 4 different studies that I'm putting into 3 minutes. In the end, I can only really talk about, I have 1 sentence per paper,
Sure.
but that gets the essence of it, right? It's the most important point, it's the most important finding, so I think that helps make it more impactful in a way.
And how did you go about preparing your presentation? Was there anything that came up that was unexpected that challenged you?
Preparing is interesting. I first obviously thought about what I wanted to say, and then I wrote it down, and I got lots of feedback on it, and practice a lot. Mm-hmm. The challenge was before the heats. My daughter was sick at home with me. She's 3 years old, so she was sick. I was like, maybe I'll have to bring her with me to the competition, but she went to daycare that day, thankfully. But she actually helped me because I would practice, and she would be like, again.
That's fantastic. And thank you so very much.
Thank you.
Thank you. Our next finalist is Megan Crooks, a master's student in psychology. Megan's thesis title is Preventing Invisible Pain with the Power of Virtual Reality.
Imagine you have a painful leg cramp. How would you feel if, when you reach down to stretch your leg, your hand just passes through thin air? This is the reality for 40 million people with leg amputations worldwide, including my friend John here. That's the entire population of Canada. This condition is called phantom pain, or pain that still haunts the leg even after it's amputated. Right now, patients like John rely on medical doctors to treat their phantom pain through medication. However, research suggests that, on average, medication is no more effective than sugar pills to treat phantom pain. Meanwhile, people like John can only walk half the distance with an artificial leg and are 3 times more likely to be clinically depressed compared to people who find relief. Here's the worst part. Effective treatment does exist, but it relies on a few specialized physiotherapists to administer it, and it can take up to 2 years to see one through the Canadian healthcare system. Luckily, my team developed a solution to make this phantom pain treatment more accessible to people like John through virtual reality, or VR. VR is like a video game that uses a headset to make you feel like you're inside of a virtual world. Our virtual world can create an illusion that can bring John's phantom leg into reality, where he can see it and move it. And once it's there, he can finally stretch his invisible cramps. I've recruited 30 people with leg amputations to try out this VR. So far, 21 of my participants have been able to self-administer this VR treatment from their hospital beds right after their amputation. So they didn't need to wait 2 years to receive care. And this is just the beginning. Previous research suggests that if we could administer this kind of treatment within 6 months following amputation, like we're already doing, it's not just more accessible. We could cut the number of people who experience phantom pain in half. That's right. This VR could mean 20 million people could have their phantom pain prevented if we can administer it early enough. John is just one of the participants that I saw in the hospital. He said he experienced phantom pain so intense, it woke him up at night. This VR gave him relief, where no medication could. Just imagine yourself from John's perspective. Imagine how relieved you would feel if you could finally have control over your invisible cramps. Thank you.
Thank you, Megan. Now, Megan, what have you learned from your research participants about how to improve this VR treatment?
So much. A lot of the patients that I see in the hospital are older adults, and as you can imagine, virtual reality doesn't come naturally to all of them. There's definitely a technological literacy gap there. Not everyone understands it the same way. So a lot of what I've been trying to do is, as they give me feedback of how it could be easier to use, I'm trying to develop it further so that people will want to use it, and it's not just that it's effective, that people actually want to use it.
So what are your next steps for the research?
Our next steps are going to be conducting a focus group where we're going to get a ton of people who tried this VR program to tell us what they think. And then afterwards, we're going to get them to try it again with the developments to see what they think.
Wonderful. Megan, thank you so much. Our third finalist is Sanjana Grover, a PhD student in human anatomy and cell science. Sanjana's thesis title is Cracking the Code of Human Brain Repair Using Zebrafish as a Model.
It's a winter weekend and you're out ice skating. The crisp air brushing against your face. Everything feels perfect until you lose your balance and hit your head. Every year, thousands of Canadians experience accidents that result in injuries. Unlike their broken bones, which can heal over time, their brain cannot. These brain injuries are a leading cause of death and lifelong disability, placing a massive burden on our healthcare system. But what if I tell you the story would be completely different if we weren't human, but a fish? Meet the zebrafish, a tiny striped swimmer, no bigger than your pinky finger, yet with an extraordinary ability to heal its brain. At a cellular level, humans and zebrafish share many similarities. Yet for the zebrafish, repairing its brain after injury is literally a no-brainer. Researchers, including myself, are fascinated by this and are asking, why can zebrafish repair their brain while we cannot? The answer lies in stem cells, which are specialized cells in the brain that can grow into new brain cells and replace the lost ones. For years, scientists believed that stem cells in the human brain were incapable of repairing damage. However, current research suggests that the problem isn't just the stem cells, but rather the brain environment they exist in. Just like the plant in your garden that needs the right nutrients in its environment to grow into a healthy tree, stem cells need the right brain environment to grow into healthy brain cells. So far, we know the right brain environment for repair is created by special proteins surrounding the stem cells. And my job is to identify these proteins that make the zebrafish brain environment repair-friendly. In my study, I compare healthy versus injured zebrafish brain to identify specific proteins that support stem cells in the healing process. For this, I use proteomic analysis, a powerful tool that uses specialized machines to break down proteins for detailed analysis. Think of it like a gardener testing the soil, examining which nutrients are present, which are absent, and how they work. Similarly, understanding the proteins that drive brain repair in zebrafish will allow us to eventually replicate this in humans. One day, we'll be able to alter the human brain's environment to promote healing. And brain injuries from a fall won't mean permanent damage. Nature has already written the blueprint for brain repair, and it's time for us to crack the code. Thank you. Oh, sorry.
Thank you so much, Sanjana. Now, research, of course, takes a lot of your time, I'm sure, but are you involved in any roles outside of your research?
Yes, absolutely. I'm very active when it comes to leadership, taking up leadership positions, and being involved in outreach and advocacy events. Just to quote some examples, I currently serve as the vice president of the HSGSA, which is the Health Sciences Graduate Student Organization. And additionally, I was invited by the Canadian Association of Neuroscience to advocate for funding and research at the Parliament Hill. So these are some of the key events I've been part of.
You're very busy. Well, tell us too, has your research been a rewarding experience for you so far?
Oh yes, definitely. I would say at a personal and professional level, it has definitely been a very a rewarding experience. First of all, I would say it has helped me, gain a lot of soft skills and improve on them. Yes, like public speaking, multitasking, time management. And because academically speaking, I've also got a couple of scholarships and awards that help me support my research. And also I've got the chance to attend different national conferences. So yeah, it has definitely been rewarding.
Wonderful. Sanjana, thank you so much.
Thank you.
Our next presenter is Lam Nguyen, a PhD student in education. Lam's thesis title is Graph Theory for Children, an inclusive approach to developing mathematical identity in the classroom.
If I put up two fractions and ask for a volunteer to explain which is greater, while some might be open to trying, I suspect that many more people would shut down at the idea of doing math in front of a crowd. I've been teaching math for almost 20 years, and I could give the steps to find the answer, but I'm less concerned that people might not remember exactly how to compare fractions than I am with the feeling they get when they encounter mathematics. I am not a math person is a phrase that many people use as a defense mechanism to let others know not to expect math thinking of them. It wrongly implies that mathematical thinking is an inherent trait and that only some people have it, based on a misconception of what math is and how we all engage with it, what we call our mathematical identity. The bad news is school contributes mostly negatively to it. The problem is what we see in math class, kids working on problems that have been broken down into steps, stripped of context, most of which can be solved in less than a minute, resembles little of what mathematicians do. Math thinkers try things out, draw pictures, make mistakes, and wrestle with ideas for months, sometimes years. Other subjects don't have this issue. English class looks like what readers and writers do. Science labs in schools resemble those in research centers. My research proposes that we take a look at why this is. Imagine instead, in class, I gave you a map and asked you to color it based on one rule. Regions that share a border can't be the same color. The map of Canada can actually be colored using just 3 colors, while some need only 2. Others need more. Then could you design a map that requires 4 or even 5 colors? The math behind this task is called graph theory and actually isn't introduced until university courses in discrete math and combinatorics. I've taught it many times to kids as young as grade 3. They jump into it without hesitation because barriers like steps to memorize have been removed. Designing tasks like this is at the core of my research, working with teachers to develop these experiences so that kids as young as 8 can engage with difficult ideas. This design is what enabled me to introduce calculus concepts to my own daughter when she was 5 using squares, triangles, and circles. So working closely with teachers to plan these activities so that kids can redefine how they see math. This is what enabled me to introduce calculus concepts to my own daughter when she was 5 using squares, triangles, and circles. So working closely with teachers to plan these activities so that kids can redefine how they see math. This is what enabled me to introduce calculus concepts to my own daughter when she was 5 using squares, triangles, and circles. So working closely with teachers to plan these activities so that kids can redefine how they see math. that is more than just steps and rules to remember, and how they see themselves related to it, that they can play with difficult ideas so that they can turn them on their side, play with math, and arrive at understanding that is their own. That way everyone is able to develop a positive mathematical identity and less people go through life believing they are not a math person. Thank you.
Thank you, Lam. What would be the reason you would say that you chose this area of research, do you think?
It's interesting. So I've been teacher for my whole career. So I lived in this space in schools, but I started noticing that everywhere I went outside of school context, with friends, at PD sessions, at dinner parties, when math came up, the phrase often followed, right? It didn't matter where I was, so it started to make me really think, what is it about all of our experiences in school math that is creating some of these negative feelings?
And you might have already addressed this, and interesting, you talk about math at dinner parties, and I'm just...
It actually becomes the focal point,
I'm sure it
right?
does.
People are quite passionate about their experiences.
I'm sure. Now, I'll just ask you quickly, Lam, how does this research relate to your work or some of your interests?
So, I'm looking at how to make education more accessible to all, right? Like we talk about school as an endeavor that we all go through, and I think a lot of kids are falling through the cracks in terms of the ability to have positive experiences and develop their identity.
Wonderful. Thank you so much,
Thank
Lam.
you.
Our next finalist is Andy Lam Nguyen, a master's student in biochemistry and medical genetics. Andy's thesis title is The Color of Risk, Using Genetics to Predict Hearing Loss and Dementia.
Imagine with me an important older adult in your life, perhaps a good friend or a close relative with whom you've shared many happy moments. If your memories are anything like mine, you might also recall painful times of isolation when your loved ones struggled to hear your voice or recognize your face. For over 700,000 older Canadians, nearly the population of Winnipeg, this scenario is more than just a memory. The combined threat of hearing loss and dementia is their daily reality. In the coming decades, as Canada's population of older adults is set to double, these conditions will place even greater pressure on our families and on our healthcare system. And because the damage from hearing loss and dementia is permanent, our best chance to alter this course is through early detection and proactive prevention. My research is taking that first crucial step towards early detection. I'm using genetics to create a tool that predicts one's risk of developing hearing loss and dementia years before symptoms appear. Picture your own DNA as a vibrant palette of colors. Each unique shade represents small differences called genetic variants that influence your traits and your health. In my visual, for example, the yellow variants in person 1 are linked to dementia, and the blue variants in person 2 are linked to hearing loss. By analyzing the unique color palettes or genetic variants for thousands of older Canadians, I will create what's known as a polygenic score, a prediction model that gathers all the variants linked to hearing loss and dementia and then assigns someone, like person 3, a risk score based on their own DNA. If, for instance, person 3 carries many variants linked to hearing loss, they would receive a high-risk score. A high-risk score acts as a warning light, alerting your doctor early so that important treatments, like hearing aids, can be prescribed. Just think, how would your life change if a simple test could warn you before permanent damage occurs? My polygenic score, like other scores before it, offers all of us a window into our future health, helping us identify risks early so we can tackle hearing loss and prevent dementia before it's too late. Now, I'd just like to go back to the beginning. Two important older adults in my own life are my grandparents, who, despite making healthy choices, are themselves burdened by hearing loss and symptoms of dementia. I have inherited many of their genetic variants, and while I can't undo what they and others have experienced, I can use my research to bring hope, prediction, and prevention to those of us who share this genetic legacy.
Thank you, Andy. Now, I'll ask you, Andy, was there a particular reason that you chose this area of research?
Yes. As we're all aware, aging is something that affects every single one of us. Mm-hmm. And frankly, we are lucky if we get to age. And with aging comes certain conditions, things that may seem unavoidable. But with recent research in genetics, with what we're learning about aging on a molecular scale, there are numerous lines of research into how we can prevent these conditions in the first place. Genetics, in my mind, is sort of a wild west in medical research. We're just scratching the surface, and I'm very excited about that.
Who would you say has been your biggest influence or maybe your biggest inspiration during your academic journey so far?
Speaking recently, I would say my advisor, Britt Drogemoller, and all of my lab members who are in their own right they're brilliant. They've inspired me every day that I come into the lab. Besides that, I'd say the professors, the teachers going back to grade school who've made contributions both small and large have, I feel, built me up to where I am. In summary, I feel like I'm standing on the shoulders of giants.
Right. Andy, thank you so much.
Thank you.
Thank you. See how fast this moves? Our sixth finalist this evening is Hayley Smith, a master's student in pharmacology and therapeutics. Hayley's thesis title is It All Started with a Mouse, Model to Study Neurodegeneration.
Every 90 minutes, someone dies from ALS. Would it shock you to know that some cases of this disease may be caused by a virus? Endogenous retroviruses, or ERVs, are a type of virus that resides within your DNA. They do have some benefits, like a role in normal human development, but as you age, these ERVs become silenced, so they're not active anymore. However, a situation could arise where these viruses become active again and can then wreak havoc on your DNA. A viral protein found in the brains of patients with ALS is the ERVK integrase enzyme, and to explain its function, I want you to imagine two ribbons. One of these ribbons is blue, and that's the viral DNA. The other is red, and that's human DNA. Scissors, or integrase, will cut the red ribbon and insert the blue ribbon into it, therefore inserting viral DNA into human DNA. Human DNA will then alert the body it has been harmed and activate a damage response to try and fix this problem. ALS, or Lou Gehrig's disease, is a fatal neurodegenerative condition. It is notably characterized by DNA damage in neurons, the cells in our brains. DNA damage leads to neuron death, which impacts the control of voluntary muscles, like your arms, legs, face, as motor neurons in the brain lose the ability to communicate with muscles in the body. So I ask, if ERVK integrase causes DNA damage, could a mouse model confirm that this viral protein leads to the onset and progression of ALS-like symptoms? My lab has already shown this in fruit flies. Now we move on to a preclinical model with mice, using a control group that does not express the viral integrase protein and a test group that does. So here integrase is on, doing its work damaging DNA. We'll run a series of behavioral tests on these mice to monitor their motor ability, which we expect will decline in the test mice compared to the controls, and continue this for 9 months or more. After, we will examine their brains with a microscope to confirm the expression of the viral protein and its association with DNA damage in brain cells. This may have started with a mouse, but by showing that a viral enzyme leads to motor dysfunction, a new world of therapeutic options is now available. Right now, there are 3 approved treatments for ALS. This research can allow us to repurpose antiviral drugs that are now used in cases like HIV and use them in ALS or other ERVK-associated diseases like cancer. By understanding the viruses within us, my project has the translational potential to provide a new model to investigate the association between viruses and neurodegenerative diseases as it becomes a platform to screen new antiviral drugs. This could change the clinical outcome for patients and give them hope for tomorrow, where little exists today. Thank you.
Thank you so much, Hayley. Now, Hayley, what would you say has been the most surprising thing that you've learned about your degree so far, or doing your degree, or the research? You know what I mean? Not about your actual degree, but doing your doing your research.
Probably the biggest thing would be learning about endogenous retroviruses. They're not really a common topic that is taught even in undergrad, and I personally didn't know about it until I interviewed from my lab this past year. So learning that about 8% of our genome is made up of viruses that are implicated in something like ALS or the cancers or dementia, schizophrenia, has just been really interesting just to learn about this whole new area of science that I hadn't been privy to before.
And of course, your graduate work no doubt takes a lot of your time, but what else do you do? Do you have any extracurricular activities?
Yes, definitely.
Okay.
I also I volunteer coach a U17 softball team that goes throughout the winter. We practice a couple times a week until we are able to get outside at some point, and I don't know, fingers crossed for May, but I don't know.
We're trying.
Other than that, just spending time with friends, reading. I love to read. I had brought a book here with me today just to calm me down before this. So yeah, I would say that's pretty much it.
Hayley, that's great. Thank you so much.
Thank you.
Our next presenter is Mia May Grabovic, a master's student in biological sciences. Her thesis title is Larval Invertebrates in a Changing Arctic Ecosystem.
Our Arctic ecosystem is a complex and intertwined web, with each component being essential in its function. In fact, over 70% of Canada's coastline is in the Arctic, making it an important resource for plants and animals, including us. Lately, Inuit communities living in the Western Canadian Arctic have reported environmental changes like less sea ice, which impacts what and where they hunt. But it doesn't stop there. Climate change is occurring 4 times more rapidly in the Arctic, causing sea ice declines, ocean warming, and acidification. These rapid shifts are impacting a critical player in the ecosystem, and my area of interest, seafloor invertebrates. Seafloor invertebrates like crabs, clams, sea stars, and sea urchins are important in their ecosystems. These organisms recycle nutrients like carbon, are food sources for birds, fish, and mammals, are habitats for others, and are used by humans. Climate change threatens them through habitat loss and population decline, making it difficult to perform ecosystem functions. However, these consequences go far beyond the seafloor. As adults, many seafloor invertebrates are sessile, meaning they stay in one place. To spread to new areas, they rely on a larval stage, which drifts using ocean currents. Larvae live and develop in the water column, making them highly sensitive to oceanic shifts. So any sudden changes alters larval abundances and impacts future seafloor invertebrate distributions. So to prevent further population decline, knowing responses to the environment at all life stages is critical. But in the Western Canadian Arctic, we lack understanding of larval stages due to microscopic sizes and being unrecognizable from their adult forms. Thus, larvae are ignored when assessing the status of seafloor invertebrates. So we don't know larval responses to climate change and how this has impacted communities over time. But I will no longer ignore larvae. I want to bring attention to larval stages in the Western Canadian Arctic by assessing abundances, distributions, and responses to climate change. I'll do this by assessing larvae in relation to environmental conditions impacted by climate change. I'll also look at larval diversity using multiple monitoring approaches. Taxonomy, which identifies organisms using their physical traits, and DNA and environmental DNA, which identifies organisms using genetic material. With my research, I will bring and share new information on the status and future condition of seafloor invertebrates in order to contribute to preserving the health of our rapidly changing and vast Arctic ecosystem.
Thank you so much, Mia May. Now, my question for you, as someone who does field work, what's your favorite thing about it?
Well, I do fieldwork in the Arctic. I go to the Beaufort Sea region, and I really enjoy going somewhere that not a lot of people get the opportunity to go and see the communities up there and see the environment. I like the cold, which is kind of surprising. It doesn't get too cold, but I enjoy that. I also enjoy collaborating with my teammates with Fisheries and Oceans Canada. We get along super well, and I think it's really good to keep positive energy and rapport, especially living on a boat for a month.
Sure.
It can get you get really close, but I really enjoy that, and it's good memories.
Was there a particular reason that you chose this area of research?
So I was in my undergrad at University of Manitoba. I wasn't really sure what I wanted to do. I went into science co-op, and through there I did an 8-month work term at Fisheries and Oceans Canada. And through that, I was learning about Arctic ecosystems, about larval invertebrates and invertebrates in general, and I really found passion in understanding their communities and how important they are in the ecosystems, because we don't look out for the little guys as much as like the mammals or the birds or the fish. So I got really into that, and then I did my first field season up there in 2023, and I just fell in love with it. And then my co-supervisor at Fisheries and Oceans Canada said I should continue a master's with them, and the rest is history.
And here you are.
Yeah.
Mia May, thank you so much.
Thank you.
Our next finalist is Taylor Orchard. Taylor is a PhD student in human anatomy and cell science. Taylor's thesis title is Musculoskeletal Education. The more a doctor knows, the better they treat.
Have you ever experienced a broken bone? Sprained a joint like your wrist or your ankle? How about pulled a muscle? If you've experienced any of these, you have injured your musculoskeletal system. Injuries to this system are the #1 cause of disability around the world. Despite this, it's been reported for the last 20 years that musculoskeletal education within medicine is inadequate. Doctors across Canada earn the same degree, but their education varies. Topics covered, time devoted to learning, even required clinical experiences are different from program to program. It's also been found that doctors lack knowledge and confidence in their musculoskeletal skills, leading to 40% of cases to be misdiagnosed. Because of this, recommendations have been made to improve education on this topic, because the more a doctor knows, the better they treat. Easy enough, right? Well, not quite. You see, doctors have the opportunity to learn topics in 4 potential environments. During medical school, they learn in the classroom, and during optional, sometimes required, clinical education experiences. When they graduate, they learn through daily practice and through continuing education opportunities. But which of these learning environments improves knowledge? Does knowledge retention vary across programs and specialties? That's where my research comes in. The goal of my project is to investigate the impact of medical education on doctors' musculoskeletal knowledge retention. To do this, I'm working with 6 different medical programs all across Canada to recruit recent medicine graduates who graduated over the last 6 years. These doctors are then asked to complete a survey that I've created that asks them about their medical education in the classroom, during optional clinical experiences, and in daily practice. On top of it, it includes a 30-question multiple choice exam that tests them on core topics in musculoskeletal medicine that all doctors should be familiar with. Thanks to this survey, I have found that those who receive musculoskeletal training during each stage of their medical journey have better knowledge. That means that we can use these findings to create continuing education opportunities within this topic, so that the next time you go see your doctor with a broken bone, a sprained joint, or a pulled muscle, they'll have the knowledge to help. By improving knowledge, we are lessening wait times for our specialists, decreasing misdiagnosis, and improving patient care. Because the more a doctor knows, the better they treat. Thank you.
Thanks, Taylor. As soon as I said it, I knew it was musculoskeletal, not skeletal. That's why you're here.
That's all right.
You're the expert. Well, let me ask you, first of all, how does your research relate to your own work or to your own interests?
Absolutely. So I grew up as a competitive dancer, so I've always really been fascinated with how the body produces movement. And so when I came to university, I started taking anatomy and I started teaching in the undergraduate anatomy course, and that really sparked a passion for anatomy education. And so when I found out about the Department of Human Anatomy and Cell Sciences and medical education research, I thought that was a perfect blend.
Perfect fit. I'll ask you too, your extracurricular activities. You're a full person. What else do you do? What do you do for fun, Taylor?
Absolutely. So in my spare time, I love spending my time up with my family and friends up in my cabin. And then in the fall and winter, I also run a dance program in my hometown community to give back to my community for all that they've done in shaping me.
That's fantastic. Taylor, thank you so much.
Thank you so much.
Thanks. Our ninth finalist tonight is Rachel Molyneux. She is a master's student in physiology and pathophysiology. Rachel's thesis title is The Spinal Symphony, How V3 Neurons Help Orchestrate the Rhythm of Movement.
Have you ever tripped over absolutely nothing? You flail your arms, catch your balance, and look around and hope no one saw? Embarrassing? Maybe a little. But that quick recovery, that was your spinal cord. We often think of the spinal cord as a simple relay system between the brain and the body, when realistically it's much more than that. It's an intricate network of neurons capable of generating complex movements. Walking, running, even catching your balance is all within the spinal cord without a second thought from the brain. Think of it like a conductor of an orchestra. The brain gives that initial cue, but it's your spinal cord that maintains the rhythm, ensuring every muscle, every musician plays in symphony. We need to understand how the symphony acts because there's 15 million people worldwide with spinal cord injuries, and that influences a lot of people. So in order to do this, we need to understand the main players in this spinal symphony. We need to understand who are our main characters responsible for maintaining the rhythm. My research focuses on one of those key players, V3 neurons. V3 neurons are essential for maintaining our left-right coordination. They're essential for making sure our steps are in sync and in balance with each other. And when they're silenced in our spinal cord, we lose rhythm. Our steps become unorganized and our movement uncoordinated. But how do they do this? Are they always active during movement, like a violin holding a note? Or do they drive in constant rhythm, like a drum driving a beat? Are they active only in the steps we take? Or are they constantly on when we're doing complex movements like balancing or jumping? These are the questions my research aims to answer. By using advanced techniques, I can track their electrical communication that they produce during real-time movement. Are they always active? Are they always quiet? Are their signals strong? Who do they communicate with across the spinal cord to ensure our steps stay in balance? By mapping out how V3s contribute to maintaining the rhythm of movement, my research helps us understand the spinal cord not just as a relay center, but as a central hub of movement generation. Because whether you're running a marathon or simply tripping over your own 2 feet, we all deserve to move through life with our own rhythm. Thank you.
Thank you, Rachel. Let me ask you, what do you think the reason was that moved you toward this area of research?
Yeah, so in my daily life, I'm a personal trainer and I work with a lot of older adults who have a lot of mobility issues. And what drove me towards this was I saw that there was a lab studying spinal cord mobility and all of the neurons that contribute to that. And I just thought, what better way to apply myself and to increase my knowledge to better help my clients and help everybody who comes to me afterwards to improve their mobility in a scientific and structured way.
And maybe you can elaborate that on a little bit, how your research helps you when you're doing your work.
Yeah, so my research really helps me understand the spinal cord and mobility in general in a more physiological and scientific way of what happens because of what type of a situation. And it allows me to, by doing things like this, it allows me to better explain to clients what's happening and what's going on and why they experience certain things over other things.
Absolutely, very important. Rochelle, thank you so much.
Thank you.
Our next finalist is Adewunmi Giwa. She is a PhD student in food science. Her thesis title is Stripping Cancer's Armor, How P Bioactive Peptides Trigger Cancer Self-Destruction.
Cancer is relentless. In Canada alone, 1 in 2 people will be diagnosed with cancer at some point in their lives, and 1 in 4 people would lose this fight. Look around you. Statistically, half of us seated in this room today would hear the words, "You have cancer." And for most of us, that fight against cancer will begin with chemotherapy, radiation therapy, and powerful synthetic drugs. But here is the sad reality. Cancer learns to fight back. Many cancer cells learn to adapt, mutate, and come back even stronger, leading to drug resistance and cancer relapses. And then there is the collateral damage. These treatments do not only attack cancer cells, they attack healthy cells too, weakening the immune system, and in many cases result in life-threatening complications. It's like burning down your entire house just to kill a pest. You might get rid of the pest, but at what cost? What if I told you cancer has a secret bodyguard, one that allows it to be able to survive even the harshest treatments? Guess what? It does. And this bodyguard is called GPX4. GPX4 is an antioxidant enzyme that acts like a bodyguard, protecting the cells in the body from damage. But here is the problem. GPX4 does not differentiate between healthy cells and cancer cells. It protects them both, allowing cancer cells to survive, resist treatment, and then come back tougher. So what if we could take away this bodyguard, but only for cancer cells? That is exactly where my research comes in. In my PhD, I am studying the ability of P-derived bioactive peptides to inhibit GPX4, specifically in cancer cells. Bioactive peptides are small fragments of proteins that have powerful biological functions. Think of cancer cells as those bad guys that have powerful bodyguards that protect them from harm. Bioactive peptides, on the other hand, are like that special tool that takes away these bodyguards by blocking their access to the bad guys. The exciting part of all of these is that cancer cells often rely on one single bodyguard, that's the GPX4, while healthy cells have multiple layers of protection. This means that when GPX4 is taken out of cancer cells, these cells are naturally going to self-destruct, while healthy cells would remain unharmed. Cancer is relentless, but so is science. And with the right tools, we can fight smarter, not necessarily harder, because nobody should have to choose between beating cancer and then surviving its treatment. Thank you.
Thank you, Adewunmi. Now, what would you say really was the main reason, or what attracted you to do this kind of research?
Okay, I would say that as far back as I can remember, like young years, when I was a child, basically, I remember I always had this curiosity about how what we eat had a direct impact on our overall health outcome. And I think this is because growing up, we had a garden, and whenever my siblings and I fell sick, my mom always knew like the right portions to mix for us, and then we got better over time, like within a couple of days. So as far back as, teen years, I knew that there were special ingredients in food, and just at that age, I knew that I wanted to explore more, so that's why I'm here today.
Is there anyone that you would say has been your biggest influence so far in your academic journey?
Yeah, actually, I would say a lot of people have influenced me in this journey, but I would say that my biggest influence would be my family, my dad, my siblings, everybody really, because I'm the last child of my family, so I have like a lot of people to, mentor me and, ensure that I'm on track. Like they basically set the path for which I currently am on. I remember as far back as a child, my siblings and I were like tutored by my parents. My dad specifically, he taught us science subjects, So basically, as far back as a child, it's just something that, my dad, then my siblings tutored me, mentored me, ensured that, I'm on track, which I'm here today. Yeah.
Terrific. Arunmi, thank you so much.
Thank you.
Our next finalist is Hannah Zhang. She's a PhD student in physiology and pathophysiology. Hannah's thesis title is Lipids as Early Markers of Cardiogenic Shock.
Celine Dion once famously sang about her heart going on in the iconic movie, The Titanic. But why exactly is that important for each and every one of us? Well, we've all heard the stats on how heart disease is one of the leading causes of death worldwide, how it kills 14 Canadians every single hour. But what is actually happening, and why is the death rate still so high in the modern age? It all comes down to the fact that every organ in our body is dependent on the heart's ability to pump blood. So when it fails, the heart is just the tip of the iceberg because the lungs, the liver, the kidneys, the brain, they're all at risk. And this multi-organ failure is a deadly condition that we call cardiogenic shock. In fact, cardiogenic shock is the #1 reason why patients will die in the hospital of a heart attack. And although a lot of research has gone into understanding this condition, nearly half of these patients will still be dead within 30 days. The main reason for this is the inability to predict which patients will develop cardiogenic shock. And therefore, the aggressive, life-saving therapies that are needed are often given too late. Now, imagine there was something that could alert doctors of impending disaster. A single blood test that could immediately change the course of treatment for high-risk patients and save their lives. Let me tell you a secret. Lipids are the key to this crisis. Now, many of you may already be familiar with some of the more common lipids like cholesterol, but there are actually thousands of different types of lipids floating around in our bodies, and they can fluctuate very quickly due to different stresses. This means that, like a ship's lookout, lipids can be used as early warning signs for specific conditions, including cardiogenic shock. Using innovative lipid measuring technologies, I've analyzed the blood of nearly 300 heart attack patients from when they first arrive at the hospital. Through this, I have identified a specific type of lipid that is strongly associated with both organ damage and poor heart function. And perhaps even more importantly, these lipids are able to accurately predict in-hospital mortality. This finding is both revolutionary and critical because it allows doctors to avoid the catastrophe of cardiogenic shock with just a simple blood test, saving hundreds of thousands of lives each year. With this new lipid-based marker, we can change the bleak narrative of cardiogenic shock to one of hope, so that the next time you or someone you love has a heart attack, not only will the heart go on, but the rest of the body will go on too. Thank you.
Thank you, Hannah. Hannah, who would you say inspired you to go ahead and pursue graduate school?
Yeah, that's a great question. I'm sure all of us have so many people in our lives that have kind of shaped the trajectory that we end up on. Obviously, I've had a lot of amazing mentors, including my supervisor, Dr. Ravandi, who's probably the smartest and most passionate person I've ever met in my life. And we kind of joke that he kind of brainwashed me into loving cardiovascular sciences. But I also have to mention my parents here. My dad, he immigrated here in 1995 from China to pursue his PhD actually here at the University of Manitoba in mathematics. And my mom actually moved shortly after him, also to do her master's here in social work. And then they became pregnant with me and had me, so I've kind of been in graduate school ever since I was in the womb.
But I think being surrounded by that, and also I grew up on this campus. I went to campus daycare down the street. I went to mini youth summer camps. My first job was here at Joyce Fromson Pool, in fact, as a lifeguard and life-saving instructor. So I think I was surrounded by this higher ed my entire life. And having parents, that also went into graduate school definitely has obviously given me a lot of privilege, but also I think has instilled in me this want to learn more, ask more questions, and I think ultimately that kind of brought me here, which is kind of a full circle moment because I started off here.
Absolutely.
Yeah.
Well, and I'll ask you as well, what extracurricular activities do you like to participate in when, of course, you have the time to do that?
Yeah, of course. So I love doing triathlons. I don't know if any of you have done it, but it's swim, bike, and run. So I actually did my first Ironman about 1.5 years ago, and upcoming this summer, my partner and I were training for a half Ironman. And then also my friend and I, we signed up for this swim run race in this archipelago between Sweden and Finland.
Wow.
So it's this really cool experience, actually. You guys should look it up.
Yeah.
You start up on this island, and you jump into the water with your running shoes on, and you swim to the next island. You get out, you run to the next body of water, you jump in, you swim to the next island, and you're tied together by a rope. So it's kind of like this
Wow.
cool, unique experience, and I'm really excited. But I love spending time outside, challenging myself, like physically and mentally too. Like all of that put together, I really enjoy.
Hannah, that's incredible.
Yeah.
Thank you so much.
Thank you.
All right, we are at our final presenter for the evening, Madhushani Ariadasu. Now, her thesis title is Nano-Based Coatings, a Way to Make Canadian Concrete Last Longer. Welcome.
What's the first impression that comes to your mind when I say concrete in Manitoba? Not a good one, huh? Yes. A significant amount of public infrastructure in Canada is aging. According to the latest infrastructure report card, 1 in 3 concrete roads and bridges are in poor condition. They require repair or reconstruction. Do you know that one of the main reasons for concrete decay is the penetration of fluids into concrete? These fluids can be water, carbon dioxide from the air, sulfate ions from the soil, chloride ion from the de-icing source, and many more. Once these fluids enter the concrete, they react with the materials inside and make the concrete weaker. Concrete coatings are a great option to prevent fluid penetration into concrete. It's just like applying sunscreen, which blocks harmful UV rays from getting into the skin. So these plain coatings have been in civil engineering practice for decades, but they do have problems. They easily debond or peel away within a couple of years of application due to the harsh weather conditions in Manitoba. Not only that, most of these plain coatings cannot withstand against these external chemical attacks. So in my research, I was able to improve the performance of these plain coatings by adding nanoparticles, which I call nano-based coatings. Once applied onto a concrete surface, it can offer beneficial attributes. Number 1, these tiny little nanoparticles, which are 1,000 times tinier than a strand of hair, can fill the small micro gaps on the concrete surface, making the surface denser and blocking the fluids from getting in. Number 2, the nanoparticles can go first themselves and block the fluids from getting in. So our 1-year field study carried on. The old Kildonor bridge check showed that the application of nano-based coatings reduced the fluid penetrability by 80%, increased the concrete surface hardness by 40%, and extended the reapplication time by 5 years compared to plain coatings even after 1 year. We as humans require different medicines to treat different health issues. Just like that, we can choose distinct nanoparticles to fight better against different durability problems faced by concrete. Thank you.
Thank you so much. Now, Madhushani, I have a very important question I think we will all be very interested in hearing the answer to. Why, oh why, do we see so many potholes in Manitoba compared to other provinces?
Yeah, there are 2 main reasons. The first reason is the reason that we all know, which is the weather conditions, where the temperature goes up to -40 during winter and up to +40 during summer. So whenever the temperature goes below zero, the entrapped water inside the concrete freezes and expands 9 times its volume than in the liquid state.
Wow.
So this expansive pressure exerting within the concrete microstructure leads to have cracking. The second reason is that, again, Manitoba has a very short construction period, again restricted by the weather conditions. So during this short period of time, the engineers and the authorities have to do a lot of tasks, which may prevent them in paying attention to certain details. Yeah.
It's a whole lot. Well, I'll ask you, having said that, what do you think we can do to improve the service life of concrete at the design stage?
Yeah. So I would like to answer to the question like this. So it is believed that for us, for human beings, if we take a proper diet, exercise regularly, sleep 7 to 9 hours per day, and manage stress, we can get rid of most of the chronic diseases unless we have a genetic predisposition. So same is applicable for concrete. If you make a concrete with good quality material, with low water to binder ratio, with a proper mix design, with a proper cement type, providing adequate curing to harden the concrete itself can withstand against a lot of durability problems. But yet it can have a genetic predisposition, such as certain vulnerability to certain type of sulfate attacks and de-icing salts. So that's when the concrete coatings come in handy.
There you go. Thank you so much, Madhushani. Fantastic. Well, everyone, those are our presenters. What do you think? What an amazing group. Yes. Thank you so much to all of our challengers for delivering such impressive presentations, I told you. And thank you to you, the audience, for your support and enthusiasm for graduate student research. Now it's time for our in-person audience and those joining us on the live stream to cast your vote for the People's Choice Award. Now on your phone, I'm sure you have it handy, or any other electronic devices, please go to menti.com. I believe it's up there. There you go, menti.com. Now you should be asked to enter a code. Now get ready, I'll give you the number. Simply enter the code 9453-7975. Again, that code is 9453-7975. Now, after you enter the code, you should see a list of all the finalist names. Click on the name of your choice, click the submit button, and that's it. You have voted. It's that easy. Alternatively, you can scan the QR code on the screen and then follow the prompts to vote for your favorite. Now, members of our illustrious judging panel, I will ask you to please convene at this point in the breakout room for your deliberations. Casey will escort you there now. Now, while the judges are busy deciding on tonight's winners, there will be a small reception, as we mentioned earlier, just outside in the Galleria. We encourage you to exit the Galleria to meet, mix, and mingle with all of our challengers. We will reconvene back here after the judges have made their selections. Now, to our virtual audience, quickly, there will be a pause while the judges are deliberating. We will be returning to announce the judges' decisions and the People's Choice Award in about 20 to 30 minutes.
Good evening, everyone. The excitement is sort of building, which is fantastic, and all of the results are right here. It's very tempting not to start to peel open some envelopes, but that is not my responsibility right now. So welcome back. Thank you all for coming back for us to this important part of the evening. So as we mentioned earlier in the program, one of the extra things that we were going to do this evening was for the winner of the Maths en 185 competition that was held earlier this month at the University of Manitoba, we're actually going to announce the winner here this evening. And so I would like to welcome Dr. Zhang, who is a professor of immunology here at the University of Manitoba, to present this award. So you didn't miss anything tonight. This happened at a different event, but we are presenting it here.
Thank you, Kelly. It's a really great honor for me to be here tonight. And you can see from my accent, I'm not Quebecois, I'm real French. And I'm sorry about that, but I think maybe I have time here to brag a little bit. Okay, the French 3MT competition, which is called, as Kelly mentioned, Mathèse en 180 secondes, actually it's way more difficult than the English 3MT. Do you know why? I can see some heads over there nodding, yes, yes, because when you have to say something in French, it's going to take you 2 lines. That, conceptualizing and shrinking hardcore concept, it's way more complicated in French than in English. Okay, but I'm proud of the English one, yes, it's okay. We are not going to say that you didn't do a bad job. And I really would like to thank you all the challenger for the English and for the French competition. And tonight I'm going to announce the French winner who is going to represent University of Manitoba and the province of Manitoba at the national competition in Quebec City at the École Polytechnique in May. And the winner is Camilla Chacon.
All right, congratulations, and let me try this. Best of luck at Mathèse en 180 secondes. Congratulations to Camilla. Now we will proceed back on the English side with the 3MT results. I know everyone is waiting with bated breath. Thank you again to our judges Lauren, Mo, and Tyler for their time, expertise, and thoughtful contributions. Thank you so much. Evaluating such talented competitors, I know, was no easy task, and we sure do appreciate your dedication in choosing tonight's winners. The awards will be presented in the following order: Challenger's Choice, People's Choice, third place, second place, and of course, first place. Finalists, if your name is called, please come on down to the stage to accept your award. A photographer will take your photo once the awards are presented. I would now like to invite Dr. Annemieke Fahrenhorst, Associate Vice President Research, back to the front to announce the Challenger's Choice recipient, a $200 University Bookstore gift card.
I feel like I'm at the Oscars here. So this is the first Challenger's Choice Award that we are giving out. So this is a very exciting event. And the winner is Hana Sung.
I would now like to invite Dr. Diane Hebert-Murphy, Provost and Vice President Academic, to announce and award the People's Choice recipient, valued at $200.
The People's Choice is awarded to Matushani Aryadasa.
All right, we are excited to announce that the third place prize value has a new sponsor for 2025. Christopher Yent, Interim Director for Blenheim and Associates, was unable to be with us here tonight and has asked Dr. Main, Dean of the Faculty of Graduate Studies, to present the $500 third prize on their behalf.
Otherwise, I wouldn't have gotten to give out one at all. So the third place that is sponsored by Blenheim and Associates goes to Taylor Orchard.
I'd now like to invite Janet Seeley, President of the Retirees Association, and Mark O'Reilly, Vice President of the Retirees Association, to announce the University of Manitoba Retirees Association prize for second place for $1,250.
On behalf of the University of Manitoba Retirees Association, I'm very pleased to announce that the second prize goes to Megan Crooks.
And here we are. Dr. Michael Benarosh, President and Vice Chancellor of the University of Manitoba, will now announce the recipient of the Dr. Archie Minicle Prize for first place. The winner will receive $2,000 and will represent the University of Manitoba at the Western Regional Competition. That's May 6th at the University of Victoria.
Thank you. So while I'm opening the envelope, very slowly, I think we should thank and congratulate all of the participants. This must have been a tough choice. They were amazing. So the Archie McNichol First Place Award goes to Hannah Zhang.
Wow. Okay, so that was fantastic. I would just like, again, to echo what everyone has been saying so far and thank everyone, to thank all of our presenters. You did a fantastic job tonight. Communicating your research in just 3 minutes is no easy task, and each of you demonstrated clarity, passion, and expertise. Your dedication to sharing your research and your knowledge in an engaging way truly highlights the impact of research beyond the academic circles. I would also like to sincerely thank our judges, to Tyler, to Lauren, and to Mo for their time and thoughtful deliberation. I'm so glad I wasn't in that role. As well as to the audience, for all of you who voted for the People's Choice, and all of your support and enthusiasm for all of our presenters this evening. And to the competitors who chose the Challenger's Choice, thank you again. I'd also like to thank all of the donors for their generous contributions. So the University of Manitoba Retirees Association, who sponsors the second prize, Blenham & Associates, who sponsored the third prize this year, to all of the challengers from all of the heats that led up to tonight's final, and all of their advisors, and all of the work that's happening in these research labs and archives and spaces within the university. And I couldn't go any farther without saying thank you to Colleen, who has the hardest job aside from the presenters in getting all of their names and all of their titles correctly and keeping us on track. So thank you very much, Colleen. I would also like to give a huge congratulations to all of the staff in the Faculty of Graduate Studies who do all of the work in getting this event and preparing for it. So you see many of them here tonight. You'll see Allison and Colton and Casey and Rebecca. There have been many more of them at the heats from the office. And the 3MT event doesn't run without Judy. Judy is the engine that drives everything that has 3MT on it, to the swag that is here, to the labels, to the signs to get you to where you're supposed to be, to the scripts for those of us who are supposed to be following and not going over 3 minutes, which I'm gonna have a hard time keeping under, to all of the competition, organization, the event, everything that you have seen here or haven't seen all runs through Judy. So thank you very much, Judy. There's only one more page, don't worry. So, finally, I would just like to thank all of you who came and attended in person, and those of you who are watching online this evening. These events don't happen without an audience of people who are listening and engaged and excited about the kinds of things that our students are doing here at the University of Manitoba. So thank you all for spending an evening with us, whether you were here in person or whether you were online, and I hope to see you again here next time. Thank you and good evening.